This is section 1.3, part 1. All right, we're going to look at solving a linear equation with variable on one side. All right, and remember, linear equations, if you were to graph them, they would form a line and linear. All right, line comes from the word linear. So part 1 is going to deal with variable on one side. The next part will actually be letter B. All right, so you'll notice that in the next video. So let's take a look at the first problem here. We've got a variable just on one side, meaning one side of the equation. If you remember in the previous videos, I mentioned an expression is one that does not have an equation, or an equal sign. All right, here we see an equal sign, so whenever you have an equal sign, you have an equation, so that's when you have to make sure you balance your equation. What you do to one side of the equal sign, you must do to the other. All right, so that's where we'll get started. All right, so when you're trying to solve an equation, you want to isolate the variable. All right, we see the variable right here. Our variable is x. We want to get x alone. So this looks like a two-step equation. One step is going to isolate or move this 8 over, and the second step will move the 6 over. And we want to deal with opposite operations here. All right, so we've got 6x minus 8 equals 10. All right, the first piece we're going to look at is this minus 8. All right, an opposite operation of subtraction is addition, because what we want to do is cancel out the 8 on this side. So I'm going to add 8 to both sides. That means I'm moving the 8 over. And so negative 8 plus 8 is 0, and that's what you want to do. You want to cancel it out. So I'm just left with 6x on the left side of the equal sign, and 10 plus 8 is 18. Now I have 18 on the right hand side. Next, we want to isolate the x. We can see 6 is attached to x through multiplication. So the opposite operation of multiplication is division. So I'm going to divide both sides by 6. 6 divided by 6 is 1, which cancels both 6's. So I'm left with just x on the left side of the equal sign. 18 divided by 6 is 3. So we see x equals 3. And we've successfully solved the equation, we think. All right, you always want to check. So by checking, you're going to go back to the original problem, and I will check in red. All right, so here's our check. We're going to go back to the original problem, which is 6x minus 8 equals 10. And I'm going to want to take the variable value, the value of this variable of x is 3, and I'm going to plug that in to x. All right, so I'm going to substitute 3 for x. So 6 times 3 minus 8 equals 10. Now I'm just going to evaluate this expression, evaluate the piece on the left side, and hopefully it's going to equal the number that's on the right. All right, so this is where your order of operations come in. If you're not following order of operations, you may have the problem right, but your check is going to be wrong. So make sure you follow your PEMDAS. So the first thing we see we have to do here is multiplication. So 6 times 3 is 18. Drop down my minus 8. Drop down your 10. 18 minus 8 is 10. Drop down your 10. And at the end, both sides should equal each other. Notice I did not move anything over to the other side of the equation in checking. You're just evaluating each side of the equation independently. All right, and we can see we've done it correctly. All right, let's try one more. All right, come down to number 2. And we've got 7 plus 5/3 x equals negative 13. So we can see the first thing we're going to want to do is move the 7 over. Whenever you have multiplication or division, all right, well, that's not necessarily the case, but in this case, all right, we want to save the multiplication and division for last. All right, so the first step here is to move over my 7. Remember opposite operations. This is a positive 7. I'm going to subtract 7 then, because the opposite of a positive is a negative. 7 minus 7 is 0. That cancels. Drop down my 5/3 x equals negative 13 minus 7. So I'm starting at negative 13, taking away another 7, so I'm at negative 20. So now I've got this 5/3 here. Fractions tend to scare people. All right, so whenever you have a fraction attached to a variable, for me the easiest way to detach it is by multiplying by the reciprocal. All right, it's just like dividing. All right, remember the definition of division. You can change division to multiplication. All right, by multiplying by the reciprocal. So I'm going to multiply both sides by the reciprocal of 5 5/3, and that's 3/5. Multiply by the reciprocal of 5/3 on this side, and that's 3/5. The 3's cancel here, the 5's cancel there, and I'm just left with x. So now I'm going to put negative 20 over 1, so it looks like I have two fractions, and I'm going to cross simplify. I can see 5 goes into negative 20. All right, that's going to become negative 4. 5 goes into itself once. So I'm going to multiply straight across. Negative 4 times 3 is negative 12. 1 times 1 is 1, so negative 12 over 1 is simply negative 12. All right, so it looks like we've done a good job, but we still need to check. So I'm going to go back to my original problem. 7 plus 5/3 x equals negative 13. I'm going to substitute the value of x, which is negative 12. I'm going to substitute negative 12 in for x. So instead of x, I've got negative 12 here. And now I need to start simplifying using PEMDAS. All right, so it looks like I've got some multiplication here. I've got this fraction multiplied by negative 12. So I'm going to put that over 1. 3 goes into 12, or negative 12. That's going to be negative 4 times. 3 goes into itself once. So I'm going to drop down my 7. 5 times negative 4 is negative 20. And then I'm going to drop down my negative 13. Last piece of simplification, 7 plus negative 20 is negative 13. And these two numbers match, so we know the equation is correct.